Hi, I'm Yusuf Abdullahi. I work as a tutor at statisticassignmentexpert.com. I'm going to explain you a solution of an assignment based on chi-square test of independence. The question is, ABC company is questioning whether the quality of material coming from the company's three supplier has something to do with the number of defective products. The number of defects from 20 production runs for each supplier were counted, and then using a 0.05 level of significance, determine whether the number of defects and the company supplying materials are related. So basically, what we want to do here is to see that if there is an association between the number of defects produced and the supplier. So in order to do this, the company has taken the number of defects from 20 production runs for each supplier, and we see that for company 1, high defects 6 and low defects 14, company 2 have 9 high defects, 11 low defects, and company 3 have 15 high defects and 5 low defects. So we want to see if the number of defects we will see is based on the company that is supplying the materials for us. So we proceed to see. So we need to use the chi-square test of independence. Chi-square test of independence because our two variables are categorical variable. So the first variable is the supplier, which is categorized into company 1, 2, 3, and then the second variable is the defect, which is low defect and high defect. So we have the first is to state the hypothesis. So the hypothesis is given as there is no H0 is there is no significant difference. There is no significant association between number of defects and company supplying material, which means that the number of defects and company supplying material are independent. The second is the alternative hypothesis that there is significant association between number of defects and company supplying material. That is, the company supplying material and the number of defects are dependent. So then we give our chi-square statistics. So the chi-square statistics is giving a summation of O minus E all squared over E, where our O is the observed frequency. Our observed frequency is these frequencies that were given to us from the question, while our expected frequency will be calculated by us. And then we said the expected frequency is calculated as NR times NC over capital N. That is, what we do is to sum the row, then we sum the column, then the grand total. So to get the expected for high defect here, we say that the total here, which is 20, multiplied by the total here, the column total 20 multiplied by the row total 30, that is 20 times 30, 600. Then we divide it by the grand total here, So that's how we calculate our expected frequency. So for all of them, we have our expected frequency as 10. Let's see. So we have 6, So we have 6, 9, 15, 14, 11 and 5. So the total here is 30, as well as here, and then the total here is 20. So the grand total is 60. Then to calculate expected for this point, we are calculating it here. We say this is our total, the column total, and this is the row total. So for this one here, we say that equals column total multiplied by the row total, everything all over the grand total. So we have 10. So that's how we can calculate for this one, as when we have the column total multiplied by the row total. Yes, sorry, this is the row total, then divided by the grand total, 10. So that's how we have all the results we had here. So everything is 10. Then we now subtract the expected from the observed. So we have 6 minus 10 minus 4 minus 1 up to the last one. So what we do basically is to categorize, is to put everything in long format instead of like this. So we say I defects, then company 1, company 2, company 3. So company 1 has 6 I defects, 9 I defects, and company 3 has 15 I defects. And then for low defects, we have company 1, company 2, company 3. So we have to, all the variables in the cell, it has to come in a long format like this. So we remove the expected, we have this, then we square the difference between the observed and expected. So our 4 square will be 16, 1 square is 1, 5 raised to power 2 is 25, 4 raised to power 2 is 16. So we add everything together. So then we now go to here. This column, we divide it with what? The expected value. So we have 16 over 10, 1.6, 1 over 10, 0.1, 25 over 10, 2.5, 16 over 10, 1.6, 1 over 10, 0.1, 2, 25 over 10, 2.5. Then we add everything together. So the sum of this column give us 8.4. So we have 8.4. So this 8.4 is our chi-square statistics. So the calculation shows that the chi-square statistic is what? 8.4. Then we need to find the critical value, or you call it the tabulated value, for the chi-square at 5% level and degree of freedom. But how do we calculate our degree of freedom? Degree of freedom for independent test, for chi-square test of independence, is row minus 1 multiplied by column minus 1, where our R is the number of row and C is the number of column. So we can see here that our data have 1, 2 rows and 1, 2, 3 columns. So it means that our degree of freedom is 2 minus 1 multiplied by 3 minus 1, which is 2. Then if we check the chi-square table, at 5% level of the significance and 2 degrees of freedom, we have 5.99. Then to now determine, are we going to reject the null hypothesis or not? So what we do is we compare our test statistics, our chi-square statistics, which is 8.4. We compare it to the value from the table, which is 5.99. if the test statistic is greater than the tabulated value, then we reject the null hypothesis. Otherwise we do not reject the null hypothesis. So the result shows that chi-square calculated is what? Is 8.4, as we have here. 8.4, yes, as we have here is 8.4. Then our tabulated value is 5.99. So which means that the calculated statistic, the test statistic, is greater than the tabulated value, 5.99. So it means that we reject the null hypothesis. So what are we rejecting? We are rejecting null hypothesis that there is no significant association between number of defects and company supplying material, that is, they are independent. So it means that if we reject H naught, we are going to accept the alternative that there is significant association between number of defects and company supplying material. That is, it means that the number of defects and company supplying material are dependent. So we have enough evidence to state that the quality of material coming from the company's steady supplier has something to do with the number of defective products that the company is producing. So that is our conclusion on the test. So we have enough evidence to conclude that number of defects and company supplying material are dependent. Thank you. For any help on statistic assignment, you can email to support@statisticassignmentexpert.com. Thank you.